Welcome to this online presentation where we're going to discuss responsible AI principles, process, people, and platform. My name is Pierre Oberholzer. I work as a lead data scientist at Modulos. Modulos is a company based in Zurich whose goal is to build a platform helping organizations to comply to new standards in terms of AI governance and responsible AI. These are the topics we're going to discuss today. We're going to motivate the use of responsible AI governance practices, evidencing the role of the responsible AI engineer who needs urgently to be supported in their work by responsible AI platform. We'll delve then into one specific responsible AI use case that will lead us to the implementation that we'll shortly cover in a separate collab notebook, while concluding this talk with a few takeaways. Artificial intelligence, in short, AI, is an emerging discipline that has demonstrated already major benefits in a wide range of industries, and is coming now with an additional wave of promises since generative AI has come to the place, both to increase productivity by optimizing benefits for companies, reducing cost, but also possibly targeting those new gains of productivity to drive systems to develop or to foster, let's say, non-P&L goals, like usually considered by AI for good, that can be directed to sustainable development goals as dictated by United Nations in particular. On the other hand, artificial intelligence, like any technology, doesn't come without risk, and those risks might ultimately lead to harms, not only on the ultimate decisions that those systems are taking, ultimately on the end users, citizens, clients, group of clients, societies, but also in the way those systems are designed and built. You might have heard on the type of training data that some LLMs have used in the recent past, where pictures of children has been found, which is obviously not an acceptable practice. Second, tools like ChatGPT have been actually using low-wage resources in Africa to label their decisions and improve their system. Also raising ethical question about what is really acceptable here to be done for the profit of a company located elsewhere. Copyrighted is also an emerging issue where more and more companies now are raising concern about the usage of their own work by central large language model. You might have heard, for instance, of the claim raised a few months back by the New York Times against OpenAI. Last but not least, some technologies come now with the label of being open source. Be cautious when using those technologies. Read the footnotes. The open source clause might actually not only always apply, and that raises also generally the ask for more transparency. So there is a balance to be found fundamentally between the benefits of those AI systems and the mitigation of the harms they might ultimately cause on different groups of end users. This is where the disciplines of responsible AI comes in. While there is no single definition of that concept, there is a general agreement to say that responsible AI is precisely the discipline that is trying to find the best balance between benefits and potential harms, while putting actually the role of the contributors at the center of those technologies. Indeed, it is actually a common mistake to think that AI systems, like machine learning systems, for instance, are ultimately the decision-taking instance that are accountable for those benefits and harms. Instead, the engineers and by extension, all the contributors involved in the development of those systems are actually taking the decision on how the system is designed, developed, deployed, hence infusing their own set of value in respect of their own set of ethical standards across all those different steps throughout the development. We do see, therefore, responsible AI as following this conceptual view. At the end, it's all about satisfying users in terms of benefits, but also mitigating harms. The contributors involved in those systems can be categorized according different buckets. One of them is to split them into providers and deployers, and those roles are going to follow processes to design, develop, and deploy AI systems while capturing across the entire life cycle the risks associated with all the decisions taken. While this has been an individual practice so far in many companies, responsible AI now is gaining traction across the world and is now covered and defined by different types of frameworks. On one end, countries might be at the origin of those new frameworks. On the other, standard, being global or local, are also now defining best practices up to implementation guidelines in relation of those high-level frameworks. We don't list here all the countries involved. You'll see in the following a more comprehensive view. The roles are not limited to the AI engineer or to the risk manager. They will also cover all stakeholders involved in the process. Compliance officer and AI governance bodies, to name two of them. The AI system remains at the center of the process. It chooses to use some specific data via some design on how this data should be sourced and, for instance, labeled. It will lead to the development of a model using, for instance, here a neural network, and ultimately deploy those models with related decisions to ultimately serve a given business goal. A business goal will be measured in terms of performance metrics, for instance, accuracy, precision, recall, F1 score, and the like. In addition to this business goal, we propose here to add throughout the life cycle process responsible goals. These are secondary goals that AI engineer should also optimize for throughout the entire life cycle. While the current list presented is not exhaustive, we do see fairness, transparency, interpretability and explainability, and security as the main three responsible goals that must be observed. In addition of those responsible goals, contributors will also have to observe and to apply at application level, but to a broader extent at organization level, additional best practices that we refer here under the umbrella of responsible governance. For instance, contributors will be asked to clearly document the design, the choice of the data, of the tooling, and all related decisions of the design, providing duty of information towards their counterparties within the organization, but also via cooperation with the authorities in place to review those AI systems. The degree of human oversight is going to be as well a critical component that has to be defined at policy level within organizations, while fostering as much as possible the upgrade of workforce towards AI literacy, conforming to human rights, and acting socially and responsibly, to name a few of those requirements. As said earlier, risk will be tracked along the entire life cycle of the machine learning, of the AI system, possibly looking already at risk inherently linked with the choice of the data, the design of the data pipelines, the selection of the model, the way those models are deployed, and ultimately being able to justify what those risks were, how they have been mitigated, and what is the resulting harm that is conscious and accepted by the organization deploying those AI systems. Here's a short list of emerging principles and regulations we see worldwide. China adopting enforceable laws and set of laws using vertical approach. India having recently also committed to enforce some regulation. The Monetary Authority of Singapore has already worked during the last 5 years, and I really refer the auditors to that one, a framework that is called FEAT, and that can be consulted also publicly, and that is adopted on a voluntary basis currently by main industry verticals and companies, especially in the APAC region. And AUA Act will be detailed in the next slide. Aside of those, we do see as well now, right, a very dynamic production of ISO standards. Some of them be already publicly available. Some of them getting getting designed that will help organization to comply, ultimately to adopt the above frameworks. AUA Act has been voted very recently. It is the first ever legal framework on AI, and it's actually working on a few concepts. The risk-based tiering that is classifying, or that will ask organization to classify their own application towards the following risk tiering: unacceptable, high, limited, and minimal. Unacceptable risk will touch some very specific applications, for instance, social credit scoring or biometric identification in some cases. And high risk will be actually address all those AI systems that might ultimately have a non-acceptable impact on harm on the end users. And this is where the nuance will start to play. Organization will need to assess by themselves if the application fall in one or the other categories, while committing to the following requirements regarding quality, the establishment of quality management system, risk management system, conformity assessment, and additional items. The fines are going to be imposed on those companies that are not compliant with those requirements, that can go up to 7% of their yearly revenue, depending on the size. As said, the contributors at the core of the design, development, deployment of those systems are, to make it short, AI engineer that will be now asked to take additional responsible duties, making them responsible AI engineers. You might have seen the picture on the left a few years back, where Google was publishing this paper showing actually to the community that the ML code, the piece of software necessary to train and deploy machine learning was actually to be considered in a much broader context of engineering tasks related to the feature extraction, the data processing, up to the monitoring of the system. And that was actually the base to define new roles, new teams around the concept of MLOps. Now we do see this entire set of discipline taking place actually within an even broader context of responsible related requirements that will touch the engineering work, but that will also go beyond, right, addressing, for instance, compliance, legal, and ethical requirements. So the responsible AI engineer will have new responsibilities, both new duties, but also new opportunities. We do believe that acting responsibly and providing AI systems that were designed and developed responsibly will also build not only comply to regulations and standards, but also improve the trust that end clients will have to those systems. And that will mirror ultimately in the roles of those responsible engineers that will be very in high demand in the next time to come. You might have heard of the Hippocrates Oath that physicians used to sign back in the days, right, in the ancient Greece. There were some revisited version for engineers of that oath, like at EPFL, that published in 1990 the Archimedean Oath, that is asking, on a voluntary basis, freshly graduated students, engineers, to accept to act diligently throughout the whole career in responsible way, according those different asks here, respecting human rights, acting responsibly throughout all the course of all actions, promoting equitable relationships, sharing all important information, etc. So to some extent, the practice of acting responsibly as an engineer, as a contributor, is already anchored in most of organizations' best practices. Now we do see an upgrade of the formalism, right? And to some extent, the protection that that responsible AI engineer will have in their organization, in the societal context, right? Released of part of those ethical requirements, because they will be actually defined and asked by top organization for which they serve. Responsible AI engineers are not alone on that journey. They need dedicated tooling. This is where Responsible AI Platform comes in, like the one that Modulos is proposing. We do see here different types of roles interacting closely together in a multi-stakeholder fashion around applications that are defined in our platform, and those applications being actually mapped to different organizations that will also carry the set of requirements. At the core, we see the responsible AI engineer and the risk manager interacting closely together while having their own respective view on the system, right, getting under consideration. There is a high importance addressed to the structuration of the content, ultimately with structuring the requirements coming from those different principles, and with structuring the actionable content that the contributors will ultimately receive and comply to. At high level, we have different frameworks that map to specific requirements that are addressed by atomic unit of work that we call controls. A control being specified in a way that its fulfillment can actually comply to different frameworks. A control itself follows a given formalism in terms of description, guidance, evidences asked to comply to its ask, plus a report template. On the risk side, in compliance with ISO standards, but also flexibly adapting to organization needs, we do propose a risk management system tailored for AI needs. Given risk taxonomies, we propose the risk executors to create or edit risks that will ultimately map to specific controls. They will have their own view, right? Following the typical risk management lifecycle, identification, estimation, mitigation, and sign-off. All that in respect of the responsible goals that are mentioned in the below, and that will actually map to those different controls. From the execution perspective, the responsible AI engineer is going to keep working on their platform of choice to design, develop, and deploy AI systems. We just build a layer around those core infrastructures and platform, and we're going to interface with engineers in two ways. Using those control as the unit of work, we're going to give AI engineers guidance on how to effectively comply to those controls while gathering evidences out of their work along the entire life cycle. We do mention here only 3 controls, but there will be actually many depending on the framework you wish to comply to and the use case you're in. For instance, here you might be asked to comply to technical documentation to mitigate a given data bias, as we'll see in the use case, or to mitigate the bias inherited from the model decisions itself. All that to serve, as always, the business goals, while mapping those different controls to risks along the risk management lifecycle we mentioned earlier. Let's now look at one specific use case. We are here in the insurance industry. The process of underwriting for insurer is about assessing, right, the risk related to a potential client to map to that risk some specific pricing for an insurance product. The process of underwriting can be accelerated by means of, for instance, AI system, in which an engine, an AI system, will decide automatically about the underwriting risk of a given individual. In that specific use case, imagine you would have trained and deployed already such an engine on a given region, northern Italy, and you're wishing to expand your very same system to the rest of the country without necessarily having captured yet data, features, and label from the overall region. There might be a risk, right, to just extrapolate your system usage to the whole region, but there is also a benefit because you might actually provide accelerated underwriting to a wider population, saving cost on your side while providing new product offering for new clients. We're going to look exactly at that use case and how you would implement it end to end just by looking at one specific control. We'll see that we can actually execute the entire AI system pipeline, for instance, here in a Colab execution platform. And at the end, we will upload specific result, looking here only at what specific control, the data, bias, and mitigation, MCF 35. Again, one control chosen amongst many others. We have built here the Colab notebook related to that use case and going through those different phases. We're going to optimize for one specific goal, that is fairness. As said, this is only one responsible goal amongst others as well. We have already set up our environment. We're going here to define a few global variables, Precisely, we're going here to use one specific data bias mitigation method that is called Shapley sample importance. We're going to process the data, and we're going to assess whether or not there is a bias in terms of fairness between those different regions. Only one result here to simplify the presentation. If we measure here the risk carried by the labels between Northeast region and rest of the country, we do see already some disparate, some differences in terms of the range covered, evidencing that potentially the rest of the country might be subject to a high risk dispersion, ultimately reflecting in bias in terms of fairness metrics chosen. We're going to use one specific technique mentioned, data bias mitigation. In short, Shapley data importance, not to be confused with the SHAP feature importance, but working actually along the similar theory, tries to evaluate for each sample in the training data the impact such a sample has ultimately on a chosen metric on the prediction itself. You can optimize this type of data mitigation for performance. We do optimize it here for fairness, and we select in particular one fairness metric that is called equal opportunity difference. That is ultimately measuring the difference of true positive rate between the two sensitive groups under consideration. We're going then to rank those different sample importance by their value, right? And all the samples that are carrying positive value in this case are actually negatively impacting our fairness metrics and are candidates to be cleaned or to be revisited. The modeling here is performed via different machine learning type of models. Here, you could also apply other techniques, post-processing techniques, as they call, like the what-if method, or using the what-if tool to tune the threshold for each of the sensitive group. We're going to skip this one and dive directly to the result part. Here, at that point, we have already run two experiments, one on the left, one on the right of the graph. The top graph is showing you the performance metrics chosen, F1 in this case, that is, by the way, improving with the data importance related cleaning. Good point for your business stakeholder. The lower graph is showing you that you're reducing the equal opportunity difference by the same mechanism, helping this way to comply to your ethical and responsible AI goals set by your ethical team or like. Once you're done with those results, you're going to log into the platform and upload those two artifacts to the control of choice. On the Modulos platform, once you enter the control MCF35, it starts with a question, a description. It also shows a possible guidance on which task to do in which order, followed by typical question you should ask yourself, and a choice of selected libraries you could try to use, and terminates with the set of documents you want to upload to demonstrate that your control is fulfilled. And you see here that you have indeed received those two artifacts from your Colab environment, one being here the reduction of your bias using the data sample importance technique. At that point, you can also write a report about your findings and put this control into review, right? And typically here, you could comment additional findings to your risk manager, for instance, saying that sample importance apparently, right? Apparently reduces right fairness bias to an acceptable value of equal opportunity difference. Please review if right satisfying, right? This goes now to the risk manager, who will open that control, see this equal opportunity difference metric, attach some risk assessment to it, engaging potentially also some materiality, and ultimately concluding on whether or not the control is deemed completed and the risk mitigated to a value that is acceptable from company and use case perspective. This concludes the presentation. I hope you managed to grasp why responsible AI governance is the discipline of choice to optimize the balance between benefits and harms led or let's say caused by the emergence of those of AI systems deployed to real life application. That you identified why responsible engineers are going to play a crucial role within this discipline, plus how responsible AI platform can ultimately help those responsible AI engineers and related roles to perform their work, not only efficiently, but also in a responsible and pleasant manner. Thank you for your attention. Don't hesitate to reach out to us for any question, comment,